This is the next video in the series about acid-base titrations. In the last video, we gave the anatomy of a titration curve and talked about where the equivalence point was, which side had excess acid or which side had excess base, and we identified the pH of some important points in the curve. So now we want to take it a step further and talk about how to calculate the pH at each individual point of a couple of curves. So we're going to look at the two base titrated curves, strong acid and weak acid. And if you'd like to do the other two curves, I encourage you to try coming up with a plan for solving those on your own to test your knowledge. Okay, so here's the first curve from the previous page. We can tell this is a strong acid, strong base curve because the pH goes from very low values to very high values. So we know we're titrating with base. And the pH of the acid region is very, very low, and the pH of the base region is very, very high, indicating both of those two pieces are going to be strong. So there's a couple of different regions of interest that we care about when we're calculating the pH that we'll talk about. So the first one is called the initial point, and that is just as it sounds. It's the very beginning situation when you have analyte in your flask and you have added 0 milliliters of your base. It's right at the starting point. We also care about this point, like we talked about before, the equivalence point. And the equivalence point is where the pH is changing by the most per unit volume and where the moles of acid and base are equal. And then we want to label our left and right halves of the picture just like we did before. So we said that this half has excess acid. And so we're going to call this half the strong acid region because there's more strong acid than strong base here. And this side has a high pH, so we said there was excess base. So we're going to call this the strong base region. So that gives us 2 points and 2 regions that we can solve for the pH for. So I'm not going to solve for the pH in this video because solving for the pH in these different areas involves skills that you have built and mastered throughout this chapter. So we're just going to talk about the problem-solving process and what skills you'll need to solve for these numbers, and you can practice doing it in your homework problems. So the initial point. At this point, all that we have in the solution is the strong acid. There's no strong base. So essentially, this is just the same as finding the pH of a normal strong acid. And we know that all we have to do to find the pH of a normal strong acid is to take the negative log of the hydronium concentration, or the concentration of the strong acid. So that one is very straightforward. The next region is the strong acid region. This is the region where we have more strong acid than we have strong base added. So it's where we've only added a little bit of the titrant. So in this case, we can still figure out the pH using the pH formula, as we did before, but some of that strong base, all of it rather, all of the strong base is going to be neutralized by the strong acid. So we'll have to do a stoichiometry DNA table to figure out how much of the strong base is neutralized. So if we're going to use a DNA table, we need to find the moles of each of the different compounds. And we'll use the DNA table because the N is for neutralize, and the strong base and the strong acid will neutralize each other. Once we're done with the DNA table, we will convert those moles back into molarity. And we'll need to remember to use the new total volume, because there will be a volume of acid and a volume of base. And so when you divide by volume to find molarity again, you'll want to use the sum of those two. And then once you have the molarity of the acid, you can plug it into the formula for pH once again. That one's not bad. You might even be able to do the DNA table in your head, but you will need to find out how much of the strong base is neutralized before you start using the pH formula. Okay, our next point of interest is the equivalence point. And as we know from our experience with titrations, this is where the number of moles of strong acid equals the number of moles of strong base. And the pH at this point is defined for a strong acid, strong base system. It is always going to be pH equals 7. So I guess technically the first step needs to be finding the number of moles of each of them, because they might have different concentrations. So find the number of moles, and if the number of moles is the same, you know you're at the equivalence point, and you can skip to pH equals 7. So those steps are a little out of order, my bad. And the final region of interest is the strong base region. And that's where we have more strong base than we do strong acid. So when we do that, it's going to look very similar to the strong acid region. We find the number of moles of each. Then we do our DNA table. And we identify how much of one is neutralized by the other and which one we have excess. And so in this region, we should find that the strong base is in excess. So we should have only strong base left after the neutralization. So we'll find our molarity using the new total volume, just like before. In this case, since our strong base is in excess, it's easier to find the pOH first, since we already have the concentration of hydroxide. So we can use our new molarity for hydroxide to find the pOH. And then, of course, the question wants to know the pH. So we can convert that to the pOH by taking 14 minus the pOH to find the pH. So at the initial point, we can just use the molarity of the strong acid. In the strong base, in the strong acid region, where the strong acid in excess, we can discover it's in excess through our DNA table and use that new volume and new number of moles to find the pH. At the equivalence points, if we find the number of moles are equal, we know we're at the equivalence point, and we can find the pH equal to 7. And in the strong base region, if we find that we have more moles of base than acid, that base neutralizes the acid, we only have base left, we find the pOH and we find the pH. So that is how we calculate the pH in a strong acid, strong base curve. The process is very similar to a strong base, strong acid curve. So the one that moves in the opposite direction, the one that was underneath it in the picture. So strong acid, strong base, and strong base to strong acid, those problem-solving techniques are going to be very similar. And we'll go ahead and make the weak system a separate video.